In today's lesson from Unit 2.1, we'll be working with using congruent triangles to make other conclusions. CPCTC stands for corresponding parts of congruent triangles are congruent. So I use the symbols there because the spaces aren't that big. If two or more triangles are proven congruent by any method, then all the corresponding angles and all of the corresponding sides are congruent as well. Now, one note, you can only use CPCTC after you have shown two triangles or proven two triangles to be congruent to each other. So we're going to take a look at how we can use this in proofs. So in our first proof, we're given information that line segment YW, that's in the center of the triangle, bisects line segment XZ. So that would mean it divides XZ into two congruent parts. So line segment XW would be congruent to line segment ZW. Now, I'm not going to write it in the proof just yet, because what we're doing right now is just planning for our proof. We're also given that line segment XY over here on this side is congruent to line segment YZ on the right-hand side. Now, if we take a look at those two triangles, the small triangles, do they appear to be congruent to each other? Well, if you take a closer look, you notice that the two triangles share this side in the center by the reflexive property. So now it certainly appears that the triangle on the left and the triangle on the right are congruent by side, side, side. So if we write that all out in our proof, then we would be able to make this conclusion. So we're trying to prove that angle XYW, that's this angle at the top, congruent to angle ZYW, that's that angle. And we would use the CPCTC theorem for the reason for that. So start off your proof with your first piece of given information, just like we did in the diagram. And go back and clear it off. We'll start from scratch. We'll say that line segment YW bisects line segment XZ, and that's given to us. So again, think about what that gives you, what that tells you. Line segment YW comes down here, and it bisects this line segment. So it creates two congruent line segments, XW and ZW. And the reason is that's just the definition of bisect. To bisect something means to divide it into two congruent parts. Okay, next, go with your other piece of given information, that line segment XY is congruent to line segment YZ. Again, that was known because it was given to us. We love given information. Okay, finally, we have to look to the diagram to come up with anything else that we can conclude for sure. And from the picture, when we have two triangles that share the side, it's really common to use the reflexive property to say that that line segment that's shared is congruent to itself. Okay, take a look at your two triangles. They do appear to be congruent. So let's say that triangle XYW is congruent to, and remember, since I started here at X and I went up to Y, I have to follow the same pattern in the second triangle. So I'd want to start at Z and go up to Y for the second name. ZYW. Triangle XYW congruent to triangle ZYW, and that's because of the side, side, side congruence postulate. And then as a result of this, we can say that angle XYW is congruent to angle ZYW. Those are the two angles here at the top of the picture, this angle, congruent to this angle. And again, the reason is going to be CPCTC, corresponding parts of congruent triangles are congruent. You don't have to write out all the words. You can just write out CPCTC, but make sure that you understand what it stands for. And again, this can only be used if beforehand you prove two triangles to be congruent. On to our second proof. In number 2, it says we're given that angle P is congruent to angle S. So let's go ahead and put that into our proof. And that's given to us. And I marked it in the diagram. Step 2, go ahead and say that O is the midpoint of line segment PS. That's also given, but we're going to use it to get a piece of information, so that's why I separated it from the first piece of given information. So if O is the midpoint of line segment PS, then that means that O has to divide line segment PS into two congruent segments. So I marked those segments congruent in the diagram, and now we'll put it in the proof. PO is congruent to SO, and the reason is definition of midpoint. That's what a midpoint does. It divides a segment into two congruent segments. Okay, we're out of given information. We're trying to prove that O is the midpoint of RQ. We'll know that O is the midpoint of RQ if we can prove that RO is congruent to QO. So again, our goal is to show that those two segments are congruent by showing that the triangles are congruent. Okay, so think about how we can figure out, or how we can prove those two triangles congruent to each other. So one thing we know for sure is that when we have intersecting lines, they form vertical angles. And we have a theorem that says vertical angles are congruent. So that's where we're going to go next. In step 4, say that angle POQ is congruent to angle SOR. And that reason again is vertical angles are congruent. Okay, take a look at your picture. You see those two small triangles? And see how we have enough information to say that they're congruent. We've got angle, side, angle, congruent to angle, side, angle. Okay, so name the first triangle any way you want, and I'm going to go with the markings and go triangle POQ, and we'll say it's congruent to triangle SOR. Remember, they have to be named in order so that their corresponding parts are congruent to each other. Okay, the theorem that supports, or the postulate that supports this, is angle, side, angle. Okay, now that we've shown that those two triangles are congruent, we can for sure say that RO is congruent to QO. Here's RO, here's QO. So RO congruent to QO. And that's by using corresponding parts of congruent triangles are congruent, CPCTC. But notice that our proof doesn't stop there. We have to use this to finish it off and say that O is the midpoint of line segment RQ. And that's just simply by definition of midpoint. If a point has divided a segment into two congruent segments, which we proved that using CPCTC, then that point has to be the midpoint of the segment. In our third example, we have a little bit of a twist. In this example, we're going to be using parallel lines. So we'll go back and review what happens when parallel lines are cut by a transversal. So our given information tells us that NO is parallel to MP. It doesn't tell us that NO is congruent to MP, but since those lines are parallel and they're cut by this transversal in the center, that does mean that the alternate interior angles are congruent. So the parallel lines are given to us, and our takeaway from that is to say that angle NOM is congruent to angle PMO. And it's been a little while since we've had to state this reason, but it is if two parallel lines are cut by a transversal, and we'll let you draw that picture to represent two parallel lines being cut by a transversal, then alternate, interior, angles are congruent. In step 3, we're going to use the other piece of given information, that angle N is congruent to angle P. So put that in your proof, mark it in the diagram. Okay, we're out of given information, so now we have to look at the diagram and see if there's anything that we can deduce or conclude just based off of the picture. Okay. Well, in here I noticed that the two triangles, triangle OPM in the top and triangle MNO in the bottom, share this side in common. Okay, so that side is shared in both, so we're going to say that ON is congruent to ON by the reflexive property. Okay, in step 5, we're ready to say that our two triangles are congruent. So you can say that triangle NOM is congruent to triangle PMO. Remember, be careful how you name them. And they're congruent by the angle side congruence postulate. Okay, we're proving those two triangles congruent because we need some other information in order to be able to say that MN is parallel to OP. Okay, MN right here, parallel to OP. We have to know that another pair of alternate interior angles are congruent to each other. So by proving the two triangles congruent, now we get to say that angle NMO, this angle right here, is congruent to, and check out the name of it, NMO is congruent to angle POM. So here's angle POM at the top, and those two angles are congruent by CPC-TC. Finally, in step 7, we get to make our final conclusion that MN parallel to line segment OP. Right, this reason is a little different than reason 2. We say if two lines are cut by a transversal, we're trying to prove that the lines are parallel, so don't say that they're parallel at this point. If two lines are cut by a transversal and alternate, interior angles are congruent, then the lines are parallel. All right, time for our last example here. So we're trying to prove that line segment MD right here is congruent to line segment BE. So if we can prove these two triangles congruent to each other, then we can say that those two segments are congruent by CPC-TC. So let's take a look at how we can do this. So setting up our proof, the first two pieces of given information tell us that we've got some parallel lines. We have AD parallel to ME, and we have MD over here parallel to BE. Remember, just because they're parallel doesn't mean that they're congruent. So put those two together in line 1. AD parallel to ME and MD parallel to BE. And that's given. Okay, our takeaway from this is to work with parallel lines, these two parallel lines being cut by this transversal, and that gives us a pair of corresponding angles congruent to each other. So first we'll say angle A congruent to angle EMB. Okay, next work with the other pair of parallel lines here and here, and that same transversal, and check it out. Gives you another pair of corresponding angles that are congruent. Angle B congruent to angle DMA. And the reason is if two parallel lines cut by a transversal, then corresponding angles are congruent. Okay, so if you take a look at our two triangles, we already have two pairs of corresponding pieces of information that are congruent. So we're 2/3 of the way to proving these triangles congruent. Our other piece of given information says that line segment EM bisects line segment AB. So that's given to us. And that's a really quick way to get a pair of congruent segments. If EM, this line segment right here, is coming in and it's bisecting line segment AB, it's dividing it into two congruent parts. So in step 4, we can make the conclusion that AM is congruent to BM, and that's by definition of bisect. Because to bisect something means to divide it into congruent parts. Okay, 5. Finally, we get to say our two triangles are congruent. Check it out. We've got angle, side, angle, congruent to angle, side, angle. So let's name those two triangles. Just follow the markings to get the order right. So let's say triangle AMD congruent to triangle MBE by angle, side, angle. And then we get to make our final conclusion that MD, check it out, last two letters of this triangle, congruent to BE, last two letters of that triangle. And again, they are corresponding parts of congruent triangles, so they're congruent. Okay, good luck on your homework. See me if you have questions, please.